Okay, let's keep doing what would we call these? Force problems with vectors. That's what I'll call it. So let's see. I'm once again taking a problem from the University of Oregon. This is zebu.uoregon.edu, and they say at takeoff, the combined actions of engines and wings on a plane produce a force of 90,000 newtons at an angle of 60 degrees above the horizontal. Okay, so let me draw a plane. Let's see. I don't want to take up too much space because I always do that, and then so the plane. It's taking off. So the plane looks like that. And the combined actions of the wings and the plane produce a force of 90,000 newtons at an angle of 60 degrees. So let me draw it like this. So at an angle of 60 degrees, so that's roughly 60 degrees. So it's usually with the horizontal that we're talking about, right? So this angle is 60 degrees. 60 degrees with the horizontal. The plane rises at a constant velocity. The plane rises at a constant velocity. So, what do we? Well, I won't go into that too much, but let's say let's call it the vertical or in the y direction. The velocity is constant. I won't write anything down. We'll just keep that in mind. In the vertical, while continuing to accelerate in the horizontal direction. A, what is the mass of the plane? So, what is the mass of the plane? So there's a key clue there. They told us that the plane rises at a constant velocity. The plane rises at a constant velocity. So notice, in the upwards direction, or we could say in the y direction, there is no acceleration. They tell us that the plane rises with a constant velocity. So what that tells us is the force, the combined action of the wing and the engine, that it's the combined force in the y direction, it's just enough to offset gravity. If it was more than gravity, if it was pushing more than gravity in the upward direction, then the plane would be accelerating upwards. And likewise, if it was if the upward force was less than gravity, the plane would be decelerating. It would be accelerating downwards. So what we have to just do is we have to figure out its upward force, or the force in the y direction, right? That's being produced by the wings and the engine, and that's going to be equal to the plane's weight. And from there we can figure out the mass of the plane. So what's the force in the y direction? So let me draw my vectors a little bit bigger. So let's say the plane is that point there, and we say we are pulling with, what does it say? 90,000 newtons. So the magnitude of this side, or this vector, is 90,000 newtons. And this is at a 60 degree angle. 60 degree angle. So what is the y component of this vector? So we can draw it like a triangle here. Let me switch colors so you don't get confused. So we just view it like a triangle. Let me turn my phone off. That's who knows who that is? It's probably a junk caller. Anyway, so in the y direction, so what is this? So we use the y direction. So let's use sine, right? Sine is opposite over hypotenuse. So we know that sine. This phone calls always throw me off. Sine of 60 degrees is equal to the opposite, which is the force in the y direction over the hypotenuse, is equal to force the y times over the hypotenuse, and that's 90,000 newtons. So the force in the y direction is equal to 90,000. 90,000 times sine of 60 newtons. And you might not remember your 30, 60, 90 triangles, but you might want to review some of your trigonometry if you don't remember the sine of 60, or you might want to take out your calculator. But the sine of 60 is square root of 3 over 2, right? Because this is a 30, 60, 90 triangle. So the force in the y direction is equal to 90,000 times the square root of 3 over 2, which is equal to 45,000 square roots of 3 newtons. So that's the force in the y direction, right? But what we also know is that has to be equal to the weight of the plane, because we have this force in the y direction, which is what we just figured out, force in the y direction, and that has to completely offset the force of gravity. Let me draw gravity in mauve. And how do we know that? How do we know that the force in the y direction completely offsets the force of gravity? Because the problem told us the plane is rising at a constant velocity. Don't let the fact that it's rising make you think that the net force is positive in the y direction. It's rising, but it's not accelerating. So that means that the upward force is completely offset by gravity, or vice versa. So this is equal to the force in the y direction, and it's equal to the force of gravity, or essentially the weight of the plane. So that's the weight of the plane. And what they want to know is what is the mass of the plane? Well, mass, force of gravity, or the weight, is equal to mass times acceleration. So force of gravity is 45,000 square roots of 3 newtons is equal to mass times, what's the acceleration of gravity? 9.8 meters per second squared. So the mass is equal to, let me get the calculator out because this is getting very messy. So the mass is equal to 3, take the square root of that, times 45,000. So that equals that. So that's the force. That's essentially the weight of the plane in kilograms. And then we divide that by 9. That's the force in the y direction in newtons. And we divide by 9.8 to get the mass of the plane in kilograms. Divided by 9.8 equals, so 7,950. Let's just round. 7,950 kilograms. 7,950 kilograms. So it's not a huge plane. I don't know. I'm just guesstimating right here. So that's the mass of the plane. So we did the first part of it. And now, what is the second part of the question? Is what is the horizontal acceleration? So how fast is the plane accelerating in the x direction? So let's just go back to this triangle. So what's the force in the x direction? Well, we know what the hypotenuse is, and we need to figure out the adjacent side. So ka toa, adjacent over hypotenuse, so cosine. So we know that the cosine of 60 degrees, and you might want to review your trigonometry if this is a little confusing. I have tons of videos on it. Is equal to the force in the x direction. This is the force in the x direction, right? Force in the x direction over the hypotenuse, which is kind of the total force, or this magnitude right here, over 90. Let me just write 90k for simplicity. So the force in the x direction is equal to 90k cosine of 60 degrees. Cosine of 60 degrees, if you got your calculator, is 1/2. So the force in the x direction is going to equal 45,000 newtons, k for 1,000. And so how fast is it going to be accelerating in the x direction? Well, we know its force. The force is 45,000. I'll ignore the units for now. We know its mass. Let's just round. Let's just say this is 8,000 kilograms. 8,000 kilograms times the acceleration. So the acceleration is going to be 45,000 divided by 8,000. So the acceleration is equal to 45,000 divided by 8,000. I'm just writing k instead of 3 more zeros. And 45 divided by 8 is what, like 5.625? Let me see, get the calculator, get an exact number. Although we are rounding, so it's a little bit. So, see, we have 45 divided by 8 is equal to 5.625. So the acceleration in the x direction is 5.625 meters per second squared. This might have seemed a little confusing, but I'm telling you, the hardest part about these problems really is the trigonometry. So if you're finding the trigonometry a little confusing, you might want to go back to the whole start from the beginning with the trigonometry playlist, and you'll review a little bit of SOHCAHTOA, and hopefully you'll relearn or rememorize 30, 60, 90 triangles, which tend to show up a lot in physics problems because they don't want you to always resort to a calculator. And I think after you review that, you'll find breaking up vectors into the x and y components fairly straightforward. And frankly, once you know your trigonometry and you feel comfortable breaking up vectors into x and y components, you can tackle, I mean, the rest of all of mechanics is really that, and it's just applications of doing that over and over again in different ways. So you should be all set. So if you're having a little trouble here, I really recommend you review that. I'll see you in the next video.